And we're back to part 2 of inferences about two means. We were continuing the example working on SpongeBob SquarePants versus the educational video. And last time we left off right here, finding the critical value. So let's talk about using the traditional method for finding our conclusion here. So our critical value was negative 1.701. Okay, so if I mark him here on 28 degrees of freedom, we would have 5% of the area in this left tail. Okay, and as usual, we then need to listen to the evidence, listen to the data, and find our test statistic. If we go back to our calculator from that 2-SAMP t-test, we'll go ahead and just cut to the chase here. Our test statistic turns out to be negative 2.715. Okay, so if we put that test statistic on here, negative 2.715, we find out that our test statistic is in the critical region, so we will reject H naught. That means we do have enough evidence at the 5% level of significance. Oops, let me slide this up. To conclude, and then let's put it into the context of the problem, that the average working memory score of the SpongeBob kids is lower than the educational video kids. Okay. All right. So we again did the traditional method, found the critical value, found out where our test statistic was. He landed in the critical region, so we reject H naught. We could also do the p-value method. So the p-value method, we look at our calculator and find out, again, our test statistic. So we write him down, negative 2.715, and our p-value, which is 0.0056, because that 6 would cause that 5 to round up. And if we take a look at our p-value is 0.0056. And how does that compare to our alpha of 0.05? Okay. Well, it's less than. And if the p-value is less than alpha, that means we have enough evidence to reject H naught. Didn't mean we proved H naught is not true, but it means we have enough evidence to go with the alternate hypothesis. So if the p is low, the null must go. We will reject H naught. And we do have enough evidence to conclude that the average working memory score of the SpongeBob video children is lower than the educational video children. And just for completion here, I'm going to write what I saw on my calculator. And again, our degrees of freedom was 28.43. And we see that we get the, in addition, we get all the means and standard deviations as well. Okay, so let's take a second here. Again, when we come to a conclusion, it doesn't prove it true, but with a p-value this small, that's pretty strong evidence that the working memory score for children who watch the SpongeBob video is lower on average than that of those who watch the educational video. Now, I found an applet collection online. It's called the Rossman Chance Applet Collection. Let me pull that one up. Okay. So it looks like this at rossmanchance.com/applets. And if I click on the link here that says randomization for 2 quantitative responses to means, and we get this, and I've gone ahead and put in the SpongeBob and educational video data here, and I clicked use the data, and it created a graph for me. Okay. So what we're going to do is we're going to pretend here that the students would have gotten the score they would have gotten irregardless of which video they watched. And we're going to shuffle these guys right here and see what happens. Okay. So mixy, mixy, and then some go each way. So in this case, the average difference, you can see down here, the average difference for the SpongeBob, or the average for the SpongeBob group with some black and red. Red was the original educational video and black was the original SpongeBob video. You can see that that group mixed up. They have an average of 29.95, and the educational video group, the other group, which has some of them mixed up, has a mean of 23.6. Okay, so let's try it again and see what happens. Okay, we get similar numbers. Let's try it a lot of times. Okay, you're starting to see sort of a bell-shaped curve here. Let's do even more times. I'm going to take a second to think about that. Now you're starting to see a real approaching the bell curve here. So let's take a look at it. So what are the chances that the difference between the educational group and the SpongeBob group is as big as it was just due to random chance? Well, if we take this 33.85 and we subtract 19.70, we get a difference that is 14.15. So let's try that. So what's the probability that the average for the second group is 14.15 greater than that of the first group? And from our 1,102 trials, 6 of those, just due to random chance, were that big of a difference. And you'll notice that, oh, check this out right here, that probability, 6 out of 1,102, is about 0.0054. And you notice that is very, very close to our p-value of 0.0056. So you can see how this relates to our p-value. Could it happen by random chance? Yes. What's the likelihood? About 1 in, I don't know, 150 or 1 in 200. Okay. Now, could that happen? Yes. Is it very likely? Not really. So the evidence is pointing to us that the educational video kids have a higher average working memory score than the SpongeBob video kids did. I would like you to go ahead and play around with this a little bit. It might help you see the statistics working here as well. So we'll end this video here and pick up on the next one talking about the confidence interval for the difference of 2 population means.